This will be a repeat of P5-3 with the assembly being done from the configured parts. So we've gone through the process. The peg was the only one that kind of did the configuration. It's easy enough to if you drew the three parts. And again, you don't have to use configurations. There are some distinct advantages, and we'll see configurations again when we get into some of the motion of analyzing how the parts move and having a static, repeatable assembly, and then one that is dynamic and capable of doing that kind of analysis. So we're going to go through the same basic process, insert the component, and we'll preview at least another one or two of the ways to bring in the parts. So we'll go with the plate as a starter. Because this is a configuration, and I changed the naming a little bit with the spacers being up through, I just renamed everything to plate. I wanted a little more consistency. Again, you're in charge, so you decide which naming convention you want to go with. If you wanted to go with the part numbers, I'm going to save those for the drawing though. So when I pick my 30 by 20, that's basically the quad, and we go ahead and position it. I also want to do the out of position. So if you recognize that you can rotate about X, we come down here to the end context, or we right click and rotate about X. But if I just bring it into position, notice the snap, it's done it a couple times. That would still be origin to origin. So I'm just going to click, and that puts it pretty much anywhere. When I highlight the origin of the assembly will show up as the magenta because I've made my selection a little more visible by going to the magenta. The origin of the part then is over here. Yeah, so this is a case where I need to float. All right, so it comes in on the F. If I drew this and I rotated it and the part comes in without any issues, we're good. You know, it saves 10 seconds. I'm going to, however, in this case, right click and float. So we want this in a perspective, a perception, that when we orient and locate this part, it makes sense to our visualization going on and rattling around inside my head. So um, we want to identify these. Now, I've mentioned the hierarchy, so I can go front plane to top plane if I want, and then I would go coincident. All right, don't quite like the way that went. All right, if I'm thinking of this coming up, then this would be a case where I would want to flip the mate alignment. Now the little box popped up. I saw it there for a second, but I didn't really wait for it to finish. So we expand out. Let me do that again. We're going to expand out, right click on the coincident, flip the mate alignment. I really don't care that it did whatever position it did. We can, as we go through this process, it's going to update those alignments. So right plane, I'm going to do a control select this time, and we'll go coincident. All right, and there is my box for the flip mate alignment, so we'll go there. All right, so the last one I want to do the mates. So if you're comfortable enough with the select control select, that's always going to be fastest. If you're not recognizing the symbols or the tooltips, then the property manager will take you to that next level. And the other advantage here is that I really don't have to hold down the control button. And I want to see which degree of freedom is left. I have 1 degree of freedom. It's not rotating. It moves basically along Z. So if I was going back to the plane process, I would be looking at the top plane or this front face, and then the front plane of the assembly. All right, and there might be an advantage to doing the back, or there's times where it's just whatever you see when you see it. All right, so we have our first component in. I'm going to go ahead and open the bracket so that there are the parts. And it is the Z bracket as the default. And I just want to illustrate a quick, let's do a tile vertically would be fine. I want to illustrate a quick way of bringing this geometry in, because both the assembly and the part are open. I can drag and drop this to the assembly. So we're going to go to mate references on the next, but this will be an introduction to mate references, that when I grab the cylinder and I drag it to another cylinder, and there's a little bit of finger contortionist type stuff here, where as soon as I place the cylinders, I get the stack of marshmallows, or cylinder to cylinder concentric, and then I can hit tab to flip the mate alignment. And when I let go, I have the concentric mate. I don't want to lock the rotation, but I could. And we'll go ahead and hit accept. All right, and I brought the Z bracket in on purpose so that we could look at changing the configuration. So if I'd brought this in as a single part and realized, oh, I really needed the C bracket here, then I would have to either do a replace, which is further down the list, and or delete and reinsert the part. So with the configurations, I can pick the C bracket, make sure to hit the check mark, and it's okay. All right, so my degrees of freedom, I have constrained what would be X and Z. I'm not moving back and forth left or right, but I can move up and down and rotate. All right, so we're going to look at a coincident, and let's do another mate reference with the paper clip, and I rotate over till I can see the face, and those become coincident. And I'm going to start using parallel for some of these, and also make the illustration that if the size changed or something like that, the geometry would update. All right, so I want to bring in another C bracket. This time I will hold down the control button, left click. Well, why don't we use the File Explorer, because that's still open. Yeah, I'm going to go this way. So the bracket is still open, and the difference between the plate is it's open in memory because it exists in the assembly, but I haven't specifically opened that part like I did the bracket. So if I grab the bracket and drag and drop, I'm not going to get that that mate reference. Now going this way, it asks me which one I want, so I'm going to go ahead and tell it the C bracket. And then we'll do the same types of things. We'll add the concentric, and I don't really want to lock the rotation. Mate alignment's okay, so lock rotation, flip mate alignment. We're good on those. I don't need to click either one of those. Okay, that takes care of my X and Y. If I move it a little closer to position, then we can do the select control select parallel. And no, I don't want to flip the mate alignment. Rotate over, select control select, and coincident. All right, so that gives me my geometry. So out of the File Explorer, I do want to check, oh, I got the design library. I do want to check if I grab the plate, well, it brought in another, or tried to bring in, oh, there was the, I had both of them selected. All right, so I canceled out of those. One of the things with the File Explorer is that occasionally, see how it kind of flickered blue there? That there is a possibility that it grabbed both of those. All right, so since it asked me for the configuration on the bracket and then the configuration on the quad or the plate, I didn't pick that up quite immediately. So let's go concentric, and then it rotated kind of weird, but it's okay. And no, I don't want to flip the main alignment or lock rotation. What I do want is an error check, that if something happens to this whole position, that this geometry will change. So if I move, well, let's see, how would that, if we changed a dimension, if something were to um, be modified and not caught, then this would generate an error because it wouldn't remain concentric. All right, so we're going to bring in the peg. Let's see what I have for my parts. So let me navigate over to my assembly assignment. Okay, and there is the peg. Now I kind of drag this in. It's going to ask me again for the configuration. If these were single parts, I would just drag and drop it and it would be fine. All right, so Control Select, Concentric. This one I actually do want to lock the rotation so I don't have to go through and pick a plane, or sort of, especially with the cylinders, we would have to take the front plane and make it parallel um, to the front plane of the assembly, something like that. So on the next one, why don't we do that? All right, so from the work area, I will drag and drop, and then select, concentric, and I'm not going to lock the rotation this time. I want to get that face with a little bit closer where I can see it. So if I just left click on one of the surfaces and drag, it will allow me to go to a closer position. Now that one, oh, my selection, I have the cylinder and the planar face, so that's why it gave me tangent. And instead I want to pick the two planar faces and make those coincident. So I see the minus sign, and again I can look at the front plane. That doesn't help me. The top plane or the right plane would work here. So top plane to the front plane of the assembly. Now if I go to try to make this coincident, it's going to give me a warning, say that it's 15 millimeters back from that face, it can't be coincident. So if I just cancel out of it, and let's see, it did, well, it still popped up the box. So let's go top plane. Now I'll do the other example, right plane and parallel. It rotates into position. It really doesn't matter what location it's staying in. All right, so if you have the Windows folder open, you can drag and drop from Windows. We can insert components. We can insert from component, existing part, and assembly. And then I haven't used the S key, and I'm just going to run through these. Stay with the ones that you're comfortable with, the ones that you're familiar with. If we go to the S key, we have the mate, and then we also have insert components from the pop-up that comes from hitting S on the keyboard. All right, so I'm going to stay with the drag and drop. We have one more. So Control left button, drag into the work area, let go of the left button, let go of the Control key. And so there's a lot going on there when I say it like that, but really once you have the muscle memory in your fingers, they just take off and do whatever they're doing with the software. So concentric, and oh, it stayed up there just long enough that I didn't lose it. So lock rotation. If I missed it, not a big deal. We would expand the component, expand the mates, and then right click, and there is our lock. Same as if we wanted to unlock or flip the mate alignment, those two are right there. That is the surest way to get to those. There are usually at least one more way to get to it, but know that those will always work. So P5-3, did I unlock one of those? Oh, concentric, coincident. Let's do a rebuild real quick and see if that goes away. All right, so it says, I missed a mate. All right, so that's why the minus sign, I picked up the minus sign when I put that one in there. So at any time I realize I missed one, we're going to go back and do a select, control select, and coincident. All right, so that's why I pay attention to the minus signs. Is it's not a big deal, but we're kind of catching things as we go. All right, and then if I go to the File Explorer, again, the PEG, apparently I closed the bracket as an open file, so notice that everything highlighted there, if I dragged all of those in, it was gonna, or if I dragged that in, it was gonna drag all of them, not just the PEG. So I want to make sure to go back and click. That's probably one of the reasons why I don't use the File Explorer as much, as I end up fumbling over some of those items. Okay, lock the rotation, go to coincident, select, control select coincident, and we have our component. So at any time, and I don't exactly know what I'm going to get, but let's go to the, if I went smaller, I would have a problem because that hole would disappear. So let's take a look at that. Maybe I go to the 30 by 90 and notice that we get the red, you're no longer in alignment. All right, and those are errors that I expect and I want to see, because if something changes unexpectedly, we want to catch it. So as long as we're changing to the 120s, 60 by 120, those are all going to be within our scope. So I need to get back to the 30 by 120, and we'll go ahead and save this. All right, so I've done a couple of these now, and we want to review P5-3. All right, and then the next introduction is we're not going to worry too much about the exploded views until we get to the drawing, so we can start doing these now. The exploded view lives inside of the assembly. We do not need a separate assembly file. We do not have to worry about it in the drawing. It is going to all be managed right here. This becomes a derived configuration, whichever configuration that we're in for the assembly. Right now we're in the default and the default display states. I'll pick up display states in the next video or two. We'll go to the exploded view, and I'm going to, we can leave the auto space on. Just be aware that if you have auto space and you pick more than one item, that it is what is going to manage the separation. If you want them to move together, we need to turn that off. All right, so I'll pick my first component, and we'll drag it up some distance, and I want 80 millimeters. And so I can update that and then hit done. And then we'll grab, well, why don't we try the auto space? I would say that I could grab the brackets and move them up as a group. Okay. And we went 80, so maybe that one gets 30. And make sure that I hit done. Let's see, I can also, if I'm in the work area and it has done what I wanted it to do, then I can just hit the right mouse button. So let's see what looks good there. All right, and then before I hit done on this one, maybe we'll go 40 with that one. And I do like round numbers for whatever reason. We can leave that at 34.717, blah, blah, whatever. All right, so if I go into the spacing and I drag the auto space a little closer, a little further away, I can kind of fine tune how that looks before I hit the done and OK. All right, so make sure that, see, I can either hit F or make sure that it stayed in the asymmetric. So F on the keyboard is to fit, zoom to fit, whoop, zoom to fit, F on the keyboard. Or if I hit any of the views, it will fill the work area and go to that view. All right, so where is this located? Under the Configurations tab, we expand out, we're in the default, we have the exploded view, and those are each of my groupings. And depending on what I've told it to do, that's what I'm going to see in that list. So if I want to collapse this, I double click on it, expand it, double click on it, or we right click and collapse, or right click and explode. And then you may have noticed the animate collapse. All right, so we have a couple of options there, and it is a good practice to start with these, and go through and try different things. We could have brought these this way, to the left and to the right, and move these around. And so at this point, it's play with the exploded view, get used to the concept, and then we'll see it a little more in the drawing.